Good morning friends, I welcome you all to my YouTube channel. So previous session we have been discussing about the determinants. So let's continue the same determinant, that is exercise 4.5. We were in the discussion of exercise 4.5. So let's continue the same discussion with the next problem. We have solved up to 8 problems. So let's continue with the session with 9th problem today. Okay. So what we need to do here also same thing. We are supposed to find the value of A inverse, right? So how to find the value of A inverse, that already we know, right? So still we will take up this problem and try to finish it. Okay. Let A is equal to 2, 1, 3. It is given matrices 4, minus 1, 0, minus 7, 2, 1. Right. So what will be determinant A? Determinant of A is 2 into minus 1 minus 0 minus 1 into 4 into 1 is 4 minus 0 plus 3 into 4 into 2 is 8 minus 7. Right. So now the value of determinant will be 2 into minus 1 is minus 2, minus 4, 8 minus 7 is minus 1. So we know that 8 minus 7 is minus 1 and minus 1 into 3 is minus 3. Okay. So now what will be the value of this? Minus 2 minus 4, that is minus 6 minus 3, that is minus 9, and it is not equal to 0. So we can say that the value of the inverse exists for this particular matrix. Okay, fine. So here, okay, determinant we have calculated. What else we need to calculate? The minors as well as cofactors, right? Once we are up to minors and then once we have calculated cofactors, then we can easily find the adjoint. Once adjoint is there, then directly we can find the A inverse, right? So minors, okay. M11 is minor of A11, that is minus 1, 0, 2, 1, so that is minus 1. M12 minor of A12, that is 4, 0, minus 7, 1, 4, 0, minus 7, 1, so that is 4, right? So we have calculated M11 and M12, then now we have to calculate M13. M13 is minor of A13, that is 4, minus 1, minus 7, 2, so it is 8 minus 7, so this is equal to 1, and one thing, this is plus 3, right? So you can see here minus 2, minus 4, 8 minus 7 is plus 1 into 3 is plus 3, so it will be what? Minus 6 plus 3 is, there is a small correction here, minus 6 plus 3 is minus 3, still it is not equal to 0, right? So once that is nothing but we can find the inverse for that. We have found out M11, M12, M13. Now M21 is minor of A21, that is 1, 3, 2, 1. So this is 1 minus 6, that is nothing but minus 5. M22 is minor of A12, minor of A12, that is 2, 3, minus 7, 1. So M22 is minor of A22, that is 2, 3, minus 7, 1, 2, 3, minus 7, 1. Okay. So what will be this value? This will be 2 plus 21. So that is equal to 23. Okay. So now at last M23. So M23 value will be minor of A23, that is 2 1 minus 7 2. 2 1 minus 7 2. This is 2 1 minus 7 2. 2 into 2 is 4 plus 7. 4 plus 7 is 11. We have found out minus up to second row. Now minus of third row. M31, right? So when it is M31, minor of A31, minus 1 3 minus 1 0. So this is 1 into 0 is 0, minus of minus 3, that is plus 3. This will be plus 3. M32 is minor of A32, that is this one, 2 3 4 and 0. 2 3 4 0. So 2 into 0 is 0, right? 4 into 3 is minus 12. M33 is minor of A33, that is minor of this one, 2 1 4 minus 1. So this is minus 2 minus 4, that will be minus 6. So these are the values for all the minors we have obtained. Now we need to obtain the values for cofactors. Alright. So directly I am going to write the values of cofactors here. Okay. Directly I am going to write. So cofactor Aij is given by minus 1 to the power I plus j into Mij. Okay. So it's given directly. Right. You can substitute in this formula or you can calculate it. Right. So let's substitute. You can directly write it by tricks or calculate that through that formula. So, but I will directly write it. A11 is minus 1. A12 is minus 4. A13 is, here it is 1, I will write it properly. 1, right? A21 is five. A22 is 23. Just a minute. A23 is minus 11. A31 is 3. A32 is 12. A33 is minus 6. So these are the values of minus and cofactors, right? So now I can write adjoint A as equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, transpose or dash also you can write. Okay. So it will be nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. Right. So now adjoint A will be equal to, what is A11 minus 1, A12 is minus 4, A13 is plus 1, A21 is 5, A22 is 23, A23 is 12, A13 is 1, just a minute, A11 is minus 1, A12 is minus 4, A13 is 1, A21 is 5, A22 is 23 and A23 is minus 11, right? Next A31 is 3, A32 is 12, A33 is minus 6. This is our required adjoint A, right? So with this we need to calculate the value of A inverse, right? So how to calculate the value of A inverse? A inverse is given by 1 over determinant A into adjoint of A, right? So that is the formula. So now using that formula, what is determinant A? Minus 3. So I can write A inverse as 1 upon minus 3 into adjoint A. What is adjoint A? Minus 1. Write it a little bit bigger. Minus 1, 5, 3, minus 4, 23, 12, 1, minus 11, minus 6. So this is how we need to find the value of A inverse. I hope you people got the method of this. We have solved many problems. There should not be absolutely any confusion in this. So now take a moment, pause the video and make a note. Guys, I hope you have understood that problem. So let's continue a similar problem, that is 10th one, right? So here they have given a 3 cross 3 matrix. Okay. Let A is equal to 1, minus 1, 2, 0, 2, minus 3, 3, minus 2, 4. Okay. So let's find what will be determinant A. So determinant A will be 1 into 2 into 4 is 8, minus 2 into minus 3 is plus 6, minus of minus 1, 0 into 4 is 0, minus of 3 into minus 3 minus 9, plus 2 into 0 into minus 2 is 0, minus 6. So I can write determinant A as equal to 8 minus 6 minus 2. So this is plus 9 into plus 1 plus 9, 2 into minus 6 minus 12. So what will be the value? Minus 2 plus 9 is plus 7, plus 7 minus 12 is minus 5, and is not equal to 0, right? So as this is not equal to 0, therefore A inverse exists. Okay, so let's try to find this. For that we need minors and cofactors. Minors. Okay, so A11, minor of A11 is M11. So M11 is this one. So this is 2 into 4 is, this particular determinant will come 2, minus 3, minus 2, 4. So 2 into 4 is 8, minus of minus 6, that is plus 6. So this will be 14. M12, minor of A12, that is 0, minus 3, 3, 4. So this is 0 plus 9, that is 9. And M13 is what? Minor of A13, so that is 0 to 3 minus 2. 0, 2, 3, minus 2. So this is 0 minus 6, that is minus 6. Next, m21, right? So what is m21? Minor of a21. So minus 1, 2, minus 2, 4. Minus 1, 2, minus 2, 4. So this is minus 1 into 4 is minus 4 plus 4, that is 0, right? This was m21. m22, so minor of a22, that is 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 minus 6. 4 minus 6 is minus 2. m23. So m23 is minor of this value. 1 minus 1, 3 minus 2. 1 minus 1, 3 minus 2. So this will be minus 2 plus 3. Minus 2 plus 3 is plus 1. m31. m31 is minor of a31, right? So this is this one. Minus 1, 2, 2, minus 3. Minus 1, 2, 2, minus 3. So this is minus 1 into minus 3 is plus 3. Plus 3 minus 4 is minus 1. Next, m32. m32 is this one. 1, 2, 0, minus 3. So this is minus 3, right? So we got the value of m32. m33. So m33 is minor of this one. 1 minus 1, 0, 2. 1 minus 1, 0, 2. 1 into 2 is 2. 2 minus 0 is 2. So we have calculated the value of all the minors. Okay. So let's find the cofactors. Finding out the cofactors. Directly I will write aij is minus 1 to the power I plus j into mij, right? So a11 is, we got 14 there, right? So that will be, just a minute, no 14, 24 is 8, then this is minus 6, right? So minus of plus 6, there is minus 6, so this will be 8 minus 6 is minus 2, right? So as it is minus 2, it will be minus 2 only here. A11, A12, you can see here, it was 0 into 4, 0, minus of minus 9, it was plus 9. So here it becomes minus 9. And A13 is, there we got it as 0. So here also it will be, sorry, A13 we got it as minus 6. So what will be the value here? It will be minus 6 only, right? So A21, so A21 the value was 0 there, so here also it will be 0. A22, so the value of A22 here we got it as 4 minus 6, that was minus 2, and here also it will be minus 2. A23, right? So we got the value as minus 2 plus 3, it was plus 1, so here it becomes minus 1. A31, so A31 was the determinant value of this one, 3 minus 4, that was minus 1, so here it will be minus 1 only. A32, we got it as minus 3, here it will become plus 3. A33, it is plus 2, here also it will remain as plus 2 only. So we got the value of all the minors as well as cofactors. Now we need to find adjoint A, then we need to find the value of A inverse, right? Adjoint A is A11, A12, A13, A21, A22, A23, A31, A32, A33 transpose. So it is nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. So we got the value of adjoint A. Now we need to find the value of A inverse. We need to substitute. Still substitution is remaining. Adjoint A. A11 is what? Here we are having -2. A12 is -9. A13 is -6. A21 is 0. A22 is -2. A23 is -1. A31 is -1. A32 is 3. A33 is 2. Right? So this is how we got the value of adjoint A. Now we need to find the value of A inverse by using this adjoint A. We know that A inverse is 1 over determinant A into adjoint A. Right? And what is this? 1 over determinant A. What is the value of determinant A? -5. So 1 by -5 into adjoint A. That is -2, 0, -1, -9, -2, 3, -6, -1, 2. Right? So this is the value of A inverse. Still you can simplify it. Right? So I can write A inverse is equal to -1 upon 5, -2, 0, -1, -9, -2, 3, -6, -1, 2. This is how we can find the value of A inverse. So now what you need to do is pause the video and make a note. Okay friends, I hope you have understood. There's a small change over here, right? So this should be 8 minus 6, that is plus 2, right? And here also this should be plus 2. So this will be what? 11 minus 12 minus 1. Still it is not equal to 0. And here we get it as minus 1. This is plus 2. So A11 also will be plus 2 only. Right? So this is minus of. Right? So minus, or if you take minus inside, it becomes, you can take minus inside, whatever is positive that becomes negative, and whatever is negative that becomes positive. Right? So you can make a note of this, make the note of that change over there. Okay friends, let's continue with the next problem. That is 11th one. It is also a 3 cross 3 matrix, but it is a mixture of algebraic as well as trigonometrical functions. Okay. Let A is equal to 1, 0, 0, 0, cos alpha, sin alpha, 0, sin alpha, minus cos alpha. Right? So what will be the value of determinant A then? Expanding it through first row, cos alpha into minus cos alpha, minus cos square alpha, minus sin alpha into sin alpha, sin square alpha. So this is minus, if I take common, so this becomes minus of cos square alpha plus sin square alpha. So minus of cos square alpha plus sin square alpha is minus 1. It becomes minus 1. So this is not equal to 0. So the determinant value is not equal to 0. So inverse exists. Minus M11, minor of this one, minus cos square alpha minus sin square alpha, that is minus 1. Right? M12, minor of this particular thing, right? 0 into 0, 0 into 0 is 0. M13 minor of A13, that is 0 into anything is 0, right? M21 minor of A21, so what will be 0 0 sin alpha minus cos alpha, that is 0. M22 minor of this one, so 1 0 0 cos alpha, 1 0 0 minus cos alpha, so it will be 1 into minus cos alpha minus cos alpha. M23 is minor of this one, 1 0 0 sin alpha, right? So minor of this one will be 1 0 0 sin alpha. 1 into sin alpha is sin alpha, right? M31, right? M31 is minor of this particular thing, right? 0 0 cos alpha sin alpha, that is 0. M32 minor of this one, 1 0 0 sin alpha, so 1 into sin alpha is sin alpha. M33, so M33 is minor of this one, 1 0 0 cos alpha, so it is cos alpha. So these are the minors, right? So we can find similarly cofactors given by Aij is equal to minus 1 to the power I plus j into Mij, right? A11 will be equal to minus 1, A12 will be equal to 0, right? A13 is also equal to 0, A21 is equal to 0, A22 is minus cos alpha, A23 is minus sin alpha, right? So A31 is 0, A32 is minus sin alpha, A33 is cos alpha. So that is how we will find minors and cofactors. So let's move on to the next part, that is adjoint of A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 transpose. So there is nothing but equal to, what is A11? Minus 1, 0, 0, 0 minus cos alpha, we will make some space, right? Minus 1, 0, 0, that is minus cos alpha here, minus sin alpha, and here 0 minus sin alpha and cos alpha transpose. Adjoint A will be equal to minus 1, 0, 0, right? Then 0 minus cos alpha minus sin alpha, then 0 minus sin alpha cos alpha. This will be our adjoint, this will be our adjoint A. With the help of this, we can easily find the A inverse, right? A inverse is given as 1 over determinant A into adjoint A. So this will be, what is determinant A? Minus 1. 1 divided by minus 1. What is the adjoint A? Minus 1, 0, 0, 0. Minus cos alpha minus sin alpha, 0 minus sin alpha cos alpha, right? So I can write A inverse as minus 1 0 0 0 minus cos alpha minus sin alpha 0 minus sin alpha cos alpha, right? So this can be easily written as, if I take minus inside, right, still we can make it bigger. If I take minus inside, minus 1 becomes plus 1, 0 as it is, 0 as it is, 0 minus cos alpha becomes plus cos alpha, this becomes plus sin alpha, 0 plus sin alpha minus cos alpha. This is how the values will go into change, right? So this is about the thing. So pause the video and make a note of this. So guys, I hope you have understood the session for today. So we are going very slowly. So in each session I am solving 3 to 4 problems. That's it, right? So that it should be very much clear to you. Whatever problems are similar, that also I am solving, because so if you solve again and again, it will be more perfect. So that is the only motto here. So keep trying different problems. We'll end up the today's session here and we'll meet in the next session. Okay, so keep trying different problems. So till then, take care. Goodbye.